What if the CO2 captured was a resource? This fifth episode on carbon capture, utilization and storage provides some answers. And let's begin with one figure. 0.8 million tons of CO2 are currently converted per year in France, 70% of which by the food industry. From building materials to chemicals, CO2 can be converted and reused in many ways. The production of fuels, still in developing stages, has great potential. Here with us, two experts to delve further into the topic. Catherine Laroche, CCU Project Manager, and Jean-Philippe Hérau, Advanced Biofuels Project Manager. Hello, and thank you for joining us.
Hello, Tiffany.
Hello, Tiffany.
Catherine, can you please, to begin with, explain to our audience the challenges of CCU, CO2 Capture and Utilization, in a circular carbon economy approach? Can you also specify the state of the art for these technologies?
Yes, CO2 can be used as a resource, either directly, for instance in food or beverage, or as a reactant in various conversion pathways. In the biological pathway, CO2 can be absorbed by living matters through photosynthesis. We can obtain algae, for instance. In the chemical pathway, CO2 is used to produce chemical compounds, medicine, or even building materials. But we have to emphasize here that all products are not at the same stage of development. Some of them are already manufactured from CO2 at industrial scale. This includes urea to produce fertilizers or plastics, and it also includes salicylic acid, which is used as a precursor for aspirin. But there are also many other syntheses that are being investigated, and their feasibility is still to be demonstrated. This is the synthesis of carboxylic acids, of organic carbonates, of isocyanates. All these compounds are intermediate for plastics. And last but not least, CO2 can be used to make fuels. And CO2-based fuels would be a great opportunity to replace at least part of the fossil fuels. The potential of CO2-based fuels is estimated between 1 and 4 gigatons of CO2 per year. This remains modest with regards to the 32 gigatons of CO2 that we emit annually.
And how does conversion work exactly? How to chemically transform a CO2 molecule?
This is really challenging because CO2 is a stable molecule, which means that it is difficult to react with other molecules. At IFPEN, we first transform the CO2 into an intermediate molecule that is more reactive. This is carbon monoxide, or CO. And from this, syngas, or synthesis gas, is formed with hydrogen, and this is the basis to produce liquid or gaseous fuels. But the reaction of conversion of CO2 into CO requires hydrogen and an energy input. For this use, hydrogen is to be produced by water electrolysis. Water electrolysis transforms water into hydrogen and oxygen and uses renewable electricity, that is electricity from wind, solar, hydraulic, or geothermal energy. Or we can also use electricity of nuclear origin. As a result, the energy which is contained in CO2-based fuels comes from electricity. And this is the reason why we talk about electrofuel or e-fuel. Jean-Philippe, now I leave you the floor to give us some insight about fuel synthesis.
Thank you, Catherine. The conversion of CO2 into CO is only the first step of the process. A second step consists in recombining carbon monoxide we produced before from CO2 with hydrogen molecules to produce synthetic fuels. This combination produces hydrocarbon molecules composed of carbon, C, and hydrogen, H, which are similar to crude oil molecules. These molecules can be converted into fuels. This recombination is based on the Fischer-Tropsch reaction discovered by two German scientists, Franz Fischer and Hans Tropsch. This process is already industrial with syngas of fossil fuel origin. This reaction is a polymerization reaction. The first step is the initiation. Two hydrogen are glued with carbon. The second step is the propagation. The carbon chain increase, and the last step is the termination to stop this formation of very long molecules.
Termination, so it means it is the last step for, it means that the product is ready to meet the fuel's specifications?
No, Tiffen. The products produced by the Fischer-Tropsch synthesis are like candle wax, but not can be used directly as fuel for the transport sector. It is necessary to align them with specifications expected for fuels, such as jet or diesel. To do this, the chains of the molecules are cut to the right length, between 10 and 13 carbons for jet, and between 14 and 22 carbons for diesel fuel. The chains are then isomerized to obtain the cold flow properties required for the use of jet at high altitudes or for the use of diesel fuel in winter. IFP Énergies Nouvelles developed the Fischer-Tropsch process in partnership with Axens and the Italian energy company Eni in the late 1990s. The process is now marketed by Axens under the name Gazelle.
So, as I understand it, converting CO2 into fuels has great potential and represents a real opportunity for the decarbonation of transport. Jean-Philippe, please, can you tell us more about this?
Yes, you're right, Stephen. Synthetic fuels like e-fuel offer an interesting solution to decarbonize the transport sector. These drop-in fuels can be blended directly with the conventional fuels. It's a real advantage since it does not require to change the existing distribution infrastructure. Today, the deployment of the e-fuel is driven by societal demand and European regulation. For example, it is one of the main solutions to decarbonize the aviation sector, which accounts for 15% of the transport sector's emissions. The European ReFuelEU Aviation Initiative, which is a part of the European package Fit for 55, aims to reduce greenhouse gas emissions by at least 55% by 2030. The objective of the incorporation of 0.7% of synthetic fuels by 2030 and 5% by 2035. The maritime sector could also be in demand for these synthetic fuels.
Thank you to both of you for all these explanations. We are now more aware of the CO2 conversion issues. This topic is still a new one and deserves to be developed. Thanks to the curious ones who have listened to this episode, and see you for the next one.